Hello and welcome to Los Alamos National Laboratory's Math and Science Academy. This video is one of several in which we will explore the Common Core standards for mathematics as they relate to teaching about rational numbers. We will be looking at rational numbers through two lenses. First, the sequential trajectory of how we bring in the simple concepts early in the students' learning in third grade and move through fourth, fifth, sixth, seventh, and ultimately eighth grade to expand into irrational numbers. The other lens that we'll look at is through the Common Core's standards for mathematical practice, which are listed here. In each video, we'll be focusing on one or more of these mathematical practices. Finally, in each video, we will be looking at the ideas presented through the lens of something we call IC Flip. IC Flip is an acronym for the way that students begin to see and understand ideas, first starting with the concrete and moving up to the very abstract and procedural. We'll start out with images, which give the student an opportunity to see something in real life that they can connect to. Use that to illustrate a concept. As we get a little bit more abstract, we will bring in some facts and language that will help the students talk about the problem or the idea at hand. And finally, towards the end of the progression, we will look at procedures which are strictly abstract using symbols and are, generally speaking, the most efficient ways, but the most abstract and difficult to understand. In this video, we'll discuss standard 5NFA.1, which is a grade 5 level standard about adding and subtracting fractions with different denominators. The mathematical practice that we'll focus on is making sense of problems and persevering in solving them. Let's look at the standard in more detail. We're working with 5.NF.A using equivalent fractions as a strategy to add and subtract fractions. 5NFA.1 is adding and subtracting fractions with unlike denominators, including mixed numbers, by replacing given fractions with equivalent fractions in such a way as to produce an equivalent sum or difference of fractions with like denominators. For example, 2/3 plus 5/4 will convert the 2/3 to 8/12, the 5/4 to 15/12, and add the like units now, twelfths. 8 plus 15 is 23/12. In general, we want them to understand this procedure, which is very abstract and really moving toward fluidity with this process. This standard is the foundation of adding fractions together, and particularly conceptually understanding this idea here will allow students to move beyond numbers and work into algebraic fractions as they get higher up in mathematics. It's a very, very important concept to understand. The standard for mathematical practice that we'll look at is making sense of problems and persevering in solving them. We're really going to focus on making sense of the problems, really understanding them, understanding what's going on underneath, rather than memorizing some sort of procedure that they just kind of go through in a rote way. This is really critical. Too often students have some sense of how to manipulate symbols, and they don't really understand what's going on underneath, and they'll make mistakes that don't make any sense, and they don't know that they don't make any sense. By understanding what's going on, they'll be able to move beyond the routine problems and tackle problems that are a little bit outside of their understanding or that they haven't seen before. The learning goals for this video begin with the big idea of adding and subtracting fractions with different denominators, including those larger than 1. The strategy that we'll be using for this is to use equivalent fractions, so we need to understand the equivalence of fractions with different denominators. Once we do that, we will learn to find a common denominator of two fractions and then do the addition. We'll also look at finding the least common denominator of two fractions, and while we're not going to focus a lot on reducing fractions here, we will introduce the idea that there are more than one common denominator sometimes, and one choice, using a smaller number, can be more effective than using the larger numbers. Secondly, we'll review and work with the factors of numbers, which help us to find common denominators, and we'll also look a little bit again at mixed numbers. The problem that we'll begin with is to find 2/3 plus 5/4, And we'll begin with a pictorial image representation to really help understand the concept of how this all works. We're going to use number squares where one square, this green square, represents one unit. So if we're going to work with thirds, what we're going to do is break this unit up into 3 even parts, and each one of these is a third. Therefore, 2/3, thirds are our units here, 2/3 is represented by the shaded region here. Now we're going to look at 5/4 and think about what that looks like. Well, we'll start with another 1. This time, because we're working with fourths, we need to break it into fourths. But you'll notice that we can't represent 5 of them. We've only got 4 of them. This is a mixed number. And when we have mixed numbers, we're going to have to move up to another whole and divide it also into fourths. And this is going to happen anytime the numerator is larger than the denominator. Because remember, the number that's in the denominator represents the number of pieces that is one whole. We've broken the whole into 4 parts. So now with 2 of these, we can represent 5/4, which is 1 and a fourth. And you can see that again as a mixed number there. So the problem is to add these together. And the problem with doing that is that these are different units. The green shaded pieces are not the same size as the orange shaded pieces. So we need to do something to remedy that. And what we're going to do is start with another 1, and let's take this and break it into thirds, because we have thirds here, and then we're going to also break it into fourths. And you'll notice by breaking it vertically into thirds and horizontally into fourths, what I get is something that looks very much like an area representation of multiplying the number 3 times the number 4 to get 12 pieces. And that is in fact what we're doing. We're multiplying 3 times 4 and getting that the common units, or one set of common units that we can use when we're working with 3 and 4, are twelfths. Each of these is a 12th of the whole, which allows us to represent either thirds or fourths in some exact number of these twelfths. A third is 4 twelfths. So this one vertical piece here is equivalent to 4 of these twelfths. Since we're trying to represent 2 of them, 2/3 will be this many twelfths, 8 twelfths. So now we've got 8 twelfths as the representation of our 2/3. We're going to do the same thing with the 5/4. 1/4 is equal to 3 twelfths now. Each of these horizontal orange bars is equal to 3 of the purple units. And when we break all of the fourths into twelfths, we've got 15 of them. You can count these up. There's 4 times 3 here. 4 times 3 is 12 twelfths. That's the whole. And 3 more gives you 15 twelfths. And now that we have the same units, they're all twelfths, we can add them together. We have the same pieces, and we get the answer 23 twelfths. So this is pictorially how we add fractions with unlike denominators. And I draw your attention to this because it really helps students to understand why is the common denominator, the common unit, equal to the product of the 2 denominators. And this helps to understand why that is. So our takeaways here is that first of all, you can't add fractions until you have common units, which means a common denominator. Denominators are units. And in order to do that, you can find a common denominator by multiplying the 2 denominators together, and you'll always get a denominator that you can use as a common one. The connection here to our standard for mathematical practice, number 7, is in really understanding the meaning of why a common denominator is the product of the 2, and how that allows us to then create the same units and add or subtract. This also works with subtraction, as we'll see in the next slide. We'll move on and do a subtraction problem, as I mentioned, and this time again we're going to use an image to help solidify the concept, but a little more abstract image. We're going to use fraction strips which don't illustrate quite as clearly why the common denominator is what it is. We're going to start with one whole, and again we're working with 5/4, So we'll break the first whole up into fourths. Once again, we see that we can't create 5/4 out of 4 of them, so we need another whole, which we'll also break into fourths. And now we can represent for our 5/4 here. And you'll notice again, it's the mixed number where we've got more than a whole. We've got 1 and a fourth for our 5/4. With our 2/3, we'll start with a whole, and we'll break it into 3 parts and shade 2 of them, just as we did before. Now the task is to subtract from 5/4 3/4. And you'll notice that we're using an example of a problem where the first value is larger than the second, so that we don't get into negative numbers. Again, we're faced with the problem that we have different units. And we know from the previous slide that the units that we need are twelfths. So we'll make a whole that's represented here that's broken into twelfths. And since we know that 1/4 is equal to 3/12, and we need 5 of them, we need another whole broken into twelfths, which allows us to represent our 5/4, and we can count up the twelfths. Or, of course, if you think about it, what we're doing is we're multiplying this 5 times the number 3, since each fourth has 3/12 in it. We multiply 5 times 3 to get the total number of twelfths. And again, in the standard of mathematical practice that we're looking at, we're trying to get students to recognize what's happening abstractly and numerically from the pictures. So we want them to try to make the leap through questioning, what did we do to get this number 15? Some kids would say, well, we counted all of these. But what we want is to move them towards being more astute and seeing, well, what I did was I took this 5, we have 5 of these, and I multiplied it by 3 because each of these fourths contains 3 of these twelfths. So I take my 5/4, multiply by 3 to get my 15. That's what we'll be doing in the procedure when we get further along. So on to our 2/3. Again, we need twelfths in order to represent 2/3. 1/3 is 4/12, and 4 times 2, in order to represent all of these 2/3, we need 8/12. And now we're going to subtract. There's no real difference between addition and subtraction once we get to this point, other than you're taking away instead of adding to. We still need the same type of units, and we have the same type of units. They're both twelfths now. So we can take our 15/12, and we're going to take this many away. So we put them in here and take them away, which leaves us 7/12 for our answer. The takeaway here are that, first of all, again, fractions must be the same units to subtract them, just like with addition. And again, that the common denominator is the product of two denominators. We're not going to show it pictorially as clearly here. A student might ask back at this step, how did you know it was 12? Well, we knew it was 12 based on the previous slide, and we just need to multiply the 4 times the 3 to get the 12. Next, we'll look at the same problem that we began this series with, 2/3 plus 5/4. But now that we've got an understanding of what's going on through the more pictorial approaches in the previous slides, we're going to go procedurally. And this time, start with the procedure of multiplying the numbers by n over n to get equivalent fractions with common denominators. So here are our two numbers, 2/3 and 5/4. And we know from our previous experience that the common denominator that we can use is 12, 3 times 4. So the 3 is going to get multiplied by 4 to give us some number of twelfths. Now when we multiplied 3 by 4, what we did was we broke the whole into 4 times as many parts, which means that each part is 4 times smaller. The twelfth is 4 times smaller than a third, and so we need 4 times as many of them to represent the same value of 2/3, the same amount of the whole. So we're going to also multiply the 2 times 4 to get 8/12. Notice what we've done actually is multiplied essentially by 4 over 4, which is similar or exactly the same, as multiplying by 1. 4 out of 4, 4 parts out of 4, 4/4 we know is 1 whole. And so what we've done is multiplying by 4 over 4, we've multiplied by 1. And that's a good way for students to recognize that we haven't changed the amount. The value 2/3 as a number is exactly the same as the number 8/12. Now, we haven't talked about multiplication yet, really, a multiplication of fractions. So if we go back and look at this, the way we want to talk about it right now is that because we have 4 times as many parts, the units get smaller. They're 4 times as many. They're 4 times as small, and therefore, in order to have the same overall value, we have to have 4 times as many of those smaller units. We haven't worked with multiplying fractions yet, but you'll recognize this process as multiplying by the fraction, in this case, of 4 over 4. When we look at 4 over 4, we recognize that it's actually equal to 1, and we haven't changed the value of 2/3 when we multiply it by 1. On to the 5/4 then. That bottom 4 needs to be multiplied by the 3 to get us to 12. And once again, we're going to multiply the numerator by 3 as well. 3/3, again, that's 1, to give us 15/12. So again, we've multiplied by 1. And so here's our equivalent fraction to 5/4 using 12ths. And of course, at this point, students hopefully can see that we could do this with any version of 1, 5 over 5 or 6 over 6 or any n over n, and end up with some equivalent fraction with any denominator we want using this method. That's the tricky part of creating the common units. Now all we need to do is add them. The 8/12 and the 15/12 get added together to give us 23/12. So here's our answer. The takeaways here are, again, a reminder that the common denominator is the product of the 2 denominators, and now we're just not even seeing that pictorially. We're doing it straight procedurally. This is a straight up procedure. And the second takeaway is that by multiplying the numerator to denominator by the same number, we get an equivalent fraction. Back to our standard for mathematical practice, this is the process of making sense of an idea. We want students to understand why it is that we can multiply by 4 over 4 and what that's doing. We've moved to a very common and efficient procedure. This is what people do all the time. The standard for mathematical practice asks that students understand this idea so that we can extend it in unfamiliar situations, which will be happening more and more as we enter the world of algebra and use letters and symbols, other kinds of symbols, and more complex numerators and denominators, and continue to work with these fractions. Next, we'll do essentially the same problem, and we'll use a procedure, but we're using numbers 6 and 8 that will illustrate the issues that arise with a least common denominator. So we begin and just illustrate how we would do it the normal way. 5/6 and 3/8, we notice that the common denominator is going to be obtained by multiplying 6 and 8, so that's 48. We multiply the 5 by 8 and get 40/8. And once again, you'll notice that this is equivalent to multiplying by 1. We're going to do this similar thing with 3/8, but now we're going to multiply the 8 by 6 to get a denominator of 48, and 3 by 6 and get an equivalent fraction of 18/48. When we add them together, we get 58/48. Now you'll notice that as I whipped through this, the connection to the images and the pictures that we started with are pretty much gone. And if this is the way we start with students, they're not really going to understand what we're doing. It's really important to do this enough times, nice and slowly, so that they can really connect all of these very abstract symbols, which is up here in Procedureville, to the images and the concept of what we're doing. But what I want to point out now is that there's another way to do this, or another insight that we want to gain here. And that comes from the fact that the numbers 6 and 8 are both factors of the number 24, which is smaller than 48. When I say factors, I mean 6 divides evenly into 24, and so does 8. And because of that, we can use 24 as our least common denominator. And you might want to ask students to try to illustrate with the number blocks that we started with in the first slide why, when you have 6 and 8, you can use either 48 or 24 as your common denominator. At any rate, if we're going to use 24, then what we need to do is make our units 4 times smaller by making 4 times as many of them to get 24ths. And then we need to multiply our 5 by 4 to have 4 times as many of the smaller units to get the equivalent fraction of 20 24ths. Likewise with the 3/8, now we have a denominator of 8, and we need to multiply it by 3 to get 24ths. And so we'll do the same thing with the numerator and get 9 24ths for our equivalent fraction. The process here is to add these together, so we will. And since they're the same units, 20 plus 9 gives us 29 24ths. Now, presumably, and if we've done this correctly, these two have to be the same. And in fact, they are. And this leads us to the idea of reducing fractions. You'll notice that 58 and 48 are both divisible by 2, which means that we could cut the denominator in half and go from 48ths to 24ths. That makes the units twice as big, and so we need to cut the numerator in half and have half as many of those units. And of course, half of 48 is our 24ths, and half of 58 is our 29. So we have just larger units, but fewer of them in this version of the fraction than we had in this one. There will be more in reducing fractions as we move forward, but this is a good example of really working with students to understand, again, the meaning beneath these abstract symbols, which is really at the core of our standard for mathematical practice. And students will need to work hard and continue to persevere to really see how this all works and recognize, when can I use a denominator other than just the product, and when should I? So our takeaways are that the least common denominator is the smallest number that is a multiple of both denominators. The smallest number that's a multiple of both 6 and 8 is the least common denominator. It's also called the least common multiple. And that using the least common denominator means smaller numbers and less simplification in the end. In our final example, we will work with the problem 3/4 plus 1/3, and we'll use a procedure that involves cross-multiplying. We're going to go through it 2 times, first with an example, and then we'll do it completely abstractly and generically. If we want to add 3/4 plus 1/3, we remember that the denominator is going to be obtained by multiplying the 4 and the 3. We multiply these, and we get the denominator of 12. The numerator, if you notice, if we were to multiply the numerator and denominator both by 3 as we did before, what we would be doing is multiplying this 3 by this 3 that's down here. And so we can see that the numerator is going to come from these two numbers, the product of those two numbers. And if we multiply them, we get 9. And that's the first part of the numerator that's the contribution from this fraction. The second part of the numerator comes from the contributions of this fraction, and you'll recall that when we made this 1/3 into 12ths, we multiplied both the numerator and the denominator by 4. So for the numerator part, we need to multiply this 4 by this 1 and add that amount. That's going to represent 4/12ths, and add that amount to the 9 that we had, and we end up with 13/12ths. So here's a complete picture of a very quick procedural way of doing this. You'll notice it does not take advantage of the possibility of using a least common denominator. This process will always use a particular common denominator that is the product of the two denominators. But it's very quick and formulaic, if you will. Students want to be able to do this because it's fast and it's accurate. And when you get to the facility of being able to work that abstractly, you'll end up doing this with fractions. But if you don't understand what's going on underneath that, there's a good chance that things will fall apart as you get into higher mathematics. So let's look at that completely abstractly. Suppose we have a over b plus c over d. This is just arbitrary fractions, a over b plus c over d. Well, you'll notice that what we did is we took the b and the d, we multiplied them, and that gave us our denominator. So our denominator is always the b times the d. The bottom of this one times the denominator of that one. That was a fortunate choice of letters. And then we took for our numerator the a and the d, and that's what I mean by cross multiplying. A times d, the cross numerator and denominator. We multiply those, and that's the first part of the numerator. And then we look at the other cross product, the b and the c, multiply those, and we get the second part of the numerator. And so we have this beautiful, very abstract, simple formula that describes how to add two fractions. Sometimes people try to memorize this. It's the very last thing I would encourage you to do or to promote to your students to do. They need to do it because they understand what's happening underneath and be able to rebuild that meaning each time they do it. And as we pointed out in a previous slide, this process is very similar to the process of subtracting, the only difference being that we can change these two plus signs to minus signs and do a subtraction. And now we've just subtracted two fractions with different denominators. This is kind of the ultimate in abstract procedure. It's an endpoint of understanding that has to be underpinned by an understanding of the images, concepts, and the facts and language that go beneath it. What we take away in the process of doing this is that when we see patterns and we can understand pictorially and physically patterns, we can start to be more and more abstract and end up with some very efficient and effective procedures. However, understanding what's underneath it is what's more important than the procedure itself, so that we know really what's going on. We'll finish with a slide that shows some mathematical writing, and we're going to use a subtraction problem, 4/5 minus 2/3. We're asking the student to find it and illustrate their process pictorially. So here we have the representation of 4/5, which is a whole broken into fifths with 4 of them shaded. Similarly, 2/3 is here, a whole broken into thirds with 2 of them shaded. And the student has wisely chosen to use vertical divisions here and horizontal divisions here so that they can represent each of these with common units, which they say, as indicated, are 15ths. In the case of the 4/5, ignore the x's right now for a minute. The 4/5 is represented by these 1, 2, 3, 4 rows, each of which has 3 cells in it. So we have 12 15ths for 4/5, and then our 2/3 is represented by these 2 rows of 15ths, which is 10 15ths. And now the student has the numeric representation of that 4/5 minus 2/3 is equal to 12 15ths minus 10 15ths. And for the subtraction, the way the student has done it is just to X out the ones that they want to subtract. So they're going to X out 10 of these, and they chose to do 2 rows of 4 plus 2 more. So there's your 10 that you're subtracting. And the result is what's left over here, this 2 15ths, and that's the result right there. No words, but very clear indication of what's happening, and obviously clear understanding of how to work with this kind of idea. So I hope you've gotten a lot out of this video. It really deals with one of the most important and most difficult to understand ideas in elementary mathematics, that being adding and subtracting fractions. And if students can get this, it's going to take them a long way in their future math. Thank you for listening.